Hello ladies and gentlemen, boys and girls. My name is Mr. Do and science is my business. You are welcome to Mr. Do Scienceworld, and today we're going to talk about calculations in one-dimensional projectile motions. The last time we dealt with the concept itself, and today we're going to look at how to solve problems. We're dealing with rare problems in solving what? How to solve projectile motions in one dimension. And most of the questions that we're picking from is coming from the West African Matric. Right, so the final year students in high school in South Africa, most of the questions are coming from their past papers. Right, so let's go straight away and begin by solving some problems. Right, but before then, let's try to remind ourselves of certain things that we have learned in terms of projectiles. We have said to you that when we talk about the projectiles, we are looking at projectiles to say that a projectile is any object which is undergoing what? The to and fro motion under the influence of gravity. That means the only force that is acting on that particular object is the what? Is the force of gravity. Right. We have dealt with two-dimensional as well, but we are going to come back later on to look at calculations under the two dimensions. So let's look at the first one. If I see a situation where an object is undergoing a vertical motion like this in an upward direction, that means that I have gotten an object and I throw the object vertically upwards. In that case, we are dealing with what? A projectile motions. If I look at an object, okay, that is also being dropped from a certain height, say I have a certain, but right now that I'm here and I'm holding it and then I drop it like this. Also, we are still speaking of what? A projectile, because the only force that is acting on the object is the what? Is the force of gravity. So that is the kind of things that we are going to look at under this particular what? This particular session. So we're going to deal with calculations on how to solve problems like this. Later on, we will come on to look at the what? The two dimension, where we'll be looking at an object which is being what? Which is being thrown, or which is undergoing a motion at a certain angle like this, and then there's an angle theta here where the velocity, initial velocity, is at a certain what? Angle. We'll be looking at the calculations of that in a later video, but for now we are only just going to look at what? One-dimensional projectile motion. So let's begin with our first question. Alright, so we're going to do with the first question. Our first question is 2018 question, which happens to be, in South Africa we deal with physical sciences. So we're going to deal with the first paper, and the first paper is the what? The physics aspect, where we're going to deal with that. And the first question that we are solving here, projectile motions falls under question number 3. So we're going to solve question number 3 in 2018 past paper, paper 1. So let's look at the question and see what the question requests from us to do. The first question says, in a competition, then participants must attempt to throw a ball vertically upwards past a point C, marked a tall vertical pole, and the point C is 3.7 meters above the ground. Point C may or may not be the what? The highest point during the what? The motion of the what? Of the ball. So one participant throw the ball vertically upwards at a velocity of 7.5 meters per second from a point that is 1.6 meters above the ground, as shown in the diagram below. And then he said you should ignore the effect of air resistance. Remember, we are dealing with a projectile, so air resistance is not considered in this situation, because air resistance is a force, but a projectile is undergoing a motion in which the only force acting is the force of gravity. Right. Question number 1 is saying that in which direction is the net force acting on the ball whilst it moves towards the point T? That is what we are given. Now let's go straight away and solve this particular problem that we are given. Let's look at it. The first thing I want you to understand is that each time that we are solving a projectile motion, you need to have a pictorial view of the problem that you are about to solve. And once you have a pictorial view of the question, then you will be able to solve the problem. So first stage of a projectile motion problem solving is give the problem that you are given in a pictorial form. Draw a picture of what you are about to solve. So let's begin from drawing a picture of what we have. Alright, so this is the pictorial view of the problem that we were given. The ball was being projected at a certain height, which was what? 1.6 meters above the ground level. So this is the ground level that we have, and this person has projected the object from this point here with a velocity of 7.5 meters per second. Now this object is being projected at this velocity, which means that the initial velocity is 7.5 meters per second. Now from the ground level to the height t is the one which happens to be the target, is what? Is 3.7 meters, right? So if you are able to hit the height, one thing you need to underline or analyze from this point is that if you are able to hit the target t from the point of projection to the what? To the height t, you can say that it is what? It is 3.7 minus what? 1.6. That means that you are having what? 2.1 meters, right? Now we want to solve the first problem that we are given. The first problem that we are given is requesting that what is going to be what? The question is asking us that in which direction is the net force acting on the ball whilst it moves towards point T? Choose from upwards or downward. Give a reason for your answer. We want to find the net force when the what? The object is at what? The net force when the object is at a point of T. Well, remember, if the object is at a point of T and we want to look for the direction of the net force, the magnitude, the direction. So what the question is requesting of us is to know the direction of the net force. What is the direction? The direction of the net force at the point of T is going to what? It's going to be downwards. Downwards. So at the point of T, the net force or the net work is going to be downwards. Why is it going to be downwards? It's downwards. The reason is because this is a projectile and the only force which is acting on this particular object is the force of gravity or the weight. And this force of gravity is always acting where? It's always acting downwards. So therefore, if we are looking for the direction is always acting where? Downwards. So that is the reason for that. The direction is downwards, and the reason is the only force, because the object is undergoing projectile motion, the only force acting on the object is the force of gravity. And if it is the force of gravity is always acting what? Downwards. If we don't want to use the force of gravity, we can call it what? The weight. Right. So let's look at the question number 2 under this particular problem. Alright, so the question number 2 under this particular problem says we should calculate the time taken by the ball to reach its what? Highest point. The time taken for the ball to reach the highest point in this situation is what the question is requesting from us to calculate. Where is the highest point? Is the highest point T? The answer is no, because there is a possibility that a participant is going to throw the ball and the ball is going to pass the point of what? T. The highest point is the point where the ball is going to undergo a momentary stop, and then the final velocity of the ball at that point is going to be what? Is going to be 0. So that is the highest point. So if I want to find that point, let's look at it from the point and say, okay, this is the point where the ball was launched, and now let's take this point. That is the turning point where the ball started returning back into the what? Into the ground. So that is the point which is the highest point. So this is the point where the object undergo what? A momentary stop. So here is what we are looking for. So we are looking from here to here. So we want this height here. And if I'm looking for the height from that point, what do I know? I know the initial velocity, whether it's VI. I know the final velocity because the final velocity is 0. Okay, the initial velocity is 7.5 meters. Remember, that is the initial velocity because this velocity or the object or the ball was thrown without an angle. So it was thrown vertically upwards. Okay, it's just like it goes on a one straight line and return on one straight line. Right, so straight away from there, we have gotten the initial velocity. We know the final velocity. What else do we know? Is there any other thing that we know in terms of the question? Well, we know the what? We know gravity because gravity is a constant. So what I'm going to do again is that I'm going to put G, and G is going to be what? 9.8 meters per second squared. Right. I have gotten my 9.8 meters per second squared as my G. So there are three things that is known to us. The next thing to do is to use the equations of motion to solve that particular problem that we are given. So let's look at it and see. There are four equations of motion that we have already learned under projectile motion. Which of them is going to be the appropriate formula for us to use to solve that particular problem? Right. So from here to here, we want the time that is going to take us to move from this point to this point. Time is what the question is requesting of us in question number 2. So if you look at the equations of motion, the appropriate formula that we use that is going to be beneficial to us is going to be what? Vf is equals to Vi plus 80. 80. The 8 here is standing for the what? The acceleration due to gravity, which is the gravity that we are looking at. Alright. Now, if you want to solve any problem like this under what projectile motion, what we need to take note of is number 1, we need to choose our direction of motion, our frame of reference, our position of reference. Now, I am going to say that anything that is going up is going to be positive. So, upward motion. Okay, anything that is going up or upward motion is positive. Okay, so I have taken anything that is going up to be positive. All the quantities that are going up, the initial velocity was going up because I take this and I throw it what? Upwards. It is going up. So therefore, my initial velocity is going to be what? Positive. So my VI is positive 7.5 what? Meters per second. Alright, per second. And then what else do I know? I know the final velocity, and the final velocity is also 0 meters per second. Alright. And then I know of G. G, we have said that acceleration is always acting downwards. So if acceleration is acting downwards, and we said anything that is going up is what? Is positive. Because the acceleration is going down, we say acceleration is what? Negative. So we're going to have that to become what? Negative 9.8 meters per second squared. Alright, sorry about that. We can make use of meters per second squared, or we call it what? Meters per second, okay, squared. So this or that means the same thing, right? I'm getting use of this these days because of the current curriculum that I'm teaching. So no problem, let's get used to that. Whether this or that, it means what? The same thing. Alright, now we have written it in this way. I need to now solve the problem. So let's go straight away, substitute the value into this and solve for what? T. Because we know the final, we know the initial, and then we know the what? The A, which is the G in this case. Okay, so let me put here G. Right, so that it will become easy for us. Now let's solve that problem. This now becomes 0 is equals to, the initial is what? 7.5, and then plus what? G, which is what? Negative 9.8, and multiply by what? T. Now that I have gotten this, I need to solve for these. This is negative, so I'll transpose that and then solve that. That is going to give me 9.8. T is equals to 7.5, and then T will be equals to what? I will divide both sides by 9.8. So quickly, let's divide both sides by 9.8. And if I do that, I am going to have what? 7.5 divided by 9.8. And then we press our calculator. And then we are getting what? I am going to leave all my answers to 2 decimal places. 2 decimal places. That means that after the decimal point, I'm going to have what? 2 digits there. Right. So if I leave all answers in 2 decimal places, I am going to have it as 0.77. Because this is 0.76530612224. And if I want it in 2 decimal places, the next number is greater than what? 5, or is equal to 5. So I need to run up. So if I run up, I am getting what? 0.77 what? Seconds. Time is measured in seconds. So question number 1 asks us to find the what? The time it will take us to move from the point of projection into the what? Into the maximum height. And that point of projection to the maximum height, it took the what? The ball 0.77 seconds to reach that point. Let's look at the next question, which is question number 2. What is the question number 2 saying? Right. If I look at the question number 2, the question number 2 is telling us, okay, this is question number 3. So this number 2, this number 1. So we're solving question 3 now. Question 3 says, determine by a means of a calculation whether the ball will pass the point T or not. We want to determine whether the ball that what the person has thrown is going to pass the point of T, or it is not going to what? Reach that particular point. Right. We know from here to this point is 3.7 meters. So one way to know, if I calculate that, and I know that the point of projection was also 1.6 meters. If I throw from here and I pass the 3.7 meters, it means that from this point and I go a height which is above this one, it means I should have a height which is more than 2.1 meters. Because if I say that 3.7 minus what? 1.6, I am going to have what? 2.1 meters. So if I calculate and I have any value which is greater than 2.1 meters, it means that the ball has passed the point of T. Because if you still don't understand, from here, okay, this is the point of projection. From this point to this point is what? Is 2.1 meters. Because from this point to this point is 3.7 meters. And from here to here is 1.6 meters. So that means from here to here is what? Is 2.1 meters. So let's begin by dealing with that calculation and see what we're going to have. Whether the ball is going to pass the point T or it's not going to reach the point T. Alright. So looking for that particular thing is just like me looking for what? The maximum height reached. So I can calculate for the maximum height reached, and after finding the value of the maximum height that the ball reached, I will see if that value is greater than this 2.1 meters, then it means that the ball passed the what? The point T. But if I calculate the maximum height reached and the ball is not, the value is not up to 2.1 meters, or it is equal to 2.1 meters, then I will say that what? If it is equal, it means it reached the point, but it never passed. But if it is what? Less than, then it means it never even reached the point of what? T. So what do I know? I know the initial velocity. I know the what? The final velocity. I know the acceleration due to gravity. And now I have calculated for what? For the time to reach the maximum height as well. So therefore, I can then make use of the formula. And the formula that is appropriate here is going to be Vf squared is equals to Vi squared plus 2G delta what? Delta y. Where delta y is representing the what? The maximum height, because we are dealing with a vertical displacement. So the delta y is representing the what? The maximum displacement. So I'm going to use that as my maximum displacement. Let's do the substitution and solve for that value. Remember, everything that here, I'm going to take everything that is going up as positive. So which means that my upward motion is positive. This sign is telling me My upward motion is here, and then it's telling me all upward motions are positive. Right. So my initial velocity is positive. My acceleration is now going to be negative. My final velocity, we can give a positive or negative because that is 0. Alright, then we can solve for what? Delta y. Alright, so let's look at it and see. This will become 0 squared is equals to 7.5 squared plus 2 multiplied by negative 9.8, and then multiplied by what? Delta y. And if I do that, this is giving me 0 is equals to let's square 7.5 and see what we're going to have. If I have 7.5 and I square that, I am going to get what I'm having, 56.25. So this is 56.25 plus what? If I multiply this by that, okay, this is going to give me a negative value because positive times negative is going to give me negative value, and that is going to give me what? Negative 19.6 what? Change in y. Okay, let me still use the change in y. So this is the value that we have there. And now I want to look for change in y, so I'll transpose that. So 19.6 change in y is equals to 56.25. And I want change in y, so therefore that is 56.25 divided by what? 19.6. And what is change in y? Right. So if I do that, I am having 56.25 divided by 19.6. And if I do that 19.6, I'm having what? I said, remember, I'm leaving all my answers in 2 decimal places. What I'm having is 2.869897959. So I'm leaving it in 2 decimal places because the 869, the 9 is greater than 5. I'm going to run up, and if I run up, I should have 2.87. What? This is displacement, therefore the unit should be what? Meters. And that is the answer to that particular what? Problem. Now we have solved this. Look at it. We are getting 2.87 meters. Compare 2.87 meters to the what? The point where we are having that we said from here to here is 2.1 meters. So if you look at this value and look at this value, we can see that 2.87 meters is greater than 2.1 meters. Therefore, we will conclude to say that the ball passed the point what? T. Which means the ball that was projected passed the what? The point T, which is here. Alright, thank you. Let's look at the next question. Alright, so let's begin with the next question. And this question is picked from November paper, that is 2017 Matric question. So let's straight away just go there and deal with that problem again. As I said to you earlier, all questions are Matric papers, and you can find projectile motion in question number 3 for your Matric question. So let's look at that now. Alright, a stone A is projected vertically upwards at a speed of 12 meters from a height h above the ground. Ignore the effect of resistance. And question number 1 is saying, calculate the time taken for the stone to reach its maximum height. Alright, so let's look at what we have here, and then we're going to draw a pictorial view of what we have, and then we'll be able to solve the problem. So here is my ground level, and now this is the point of projection, and the point A is on the side, so A is here. Right, so if I have A here, this is the height h which was given. H value is not yet determined. Right, so it is unknown to us, and if you look at the question from this point, we were told that the ball has been projected vertically upwards, so which means that it was up this way, it went up until it got to a point of momentary stop, and then from there it returned back into the ground. So to get back into the ground here, which is going to be the final destination for the stone that we have. But one thing that we need to take note of is that here the ball was having an initial velocity which is what? 12 meters per second. The ball has gotten to this point, that is the what? The point of momentary is what? Is your final destination in space before it starts returning back. So from this point here, I can calculate from here, and it's okay. From here to here is going to be the maximum height for the stone A, because it was projected from this point until it got to that point. So this is the maximum height for the stone A. And at this point here, the final destination in space is going to be our final velocity, which is what? Which is 0, because at that point the ball had what? The stone had a momentary stop. So we're going to start from there and see what is the question requesting of us to do. We should calculate the what? The time taken for the stone A to reach its maximum what? Height. Alright, so which formula according to the equations of motion is going to be appropriate for us to make use of? And that is going to be my VF, okay, is equals to VI plus AT. Alright, so A, as I said to you, we're dealing with what? Acceleration due to gravity, so we can make use of what? Our G, which is the same thing there. From this point now, let's see what we need to do. The next thing to do is to choose our direction of motion or our frame of reference. And that means that we're going to make what? My upward motion to be what? Positive. So all the quantities that are going up is going to be positive. Anything going up is positive. So I can just simply do this, or you can just write there and say what? Your upwards motion, okay, is what? Is positive. Right. Let me just use positive here. Right. Straight away. What do I know? I know my initial velocity. I know the final velocity. And then I know acceleration due to gravity, because it's a constant, and that is what? 9.8 meters per second squared. And now what I need to find is the what? Is the time. So let's try and do that straight away and see. Okay. So the values that is known to me here, I know my G, which is 9.8 meters per second squared. Check something. I said my upward motion is positive. The velocity, initial velocity, is where? It is going up. So if it is going up, that should be what? Positive. So the 12 is positive. Then my final velocity is 0, so we can say it's positive or negative, because we can give a what? A sign to a negative what? To 0 number. And then my G, acceleration due to gravity is always acting downwards. So if it is acting downwards, and I said anything going up is positive, therefore I am going to take that to become what? Negative, because that is going down. So that's negative. And then let's do the calculations from here. I'm going to do a substitution from here. So this is going to be 0 is equals to 12 is positive. So that's 12 plus negative 9.8 multiplied by what? By my T, which is the time. And what I need is the time. So therefore, I'll transpose from here to this side. 0 is out there. So I'll have 9.8 T. Because here is negative. If I transpose that, that should give me what? A positive value. And then what I want is to find my T. So I'll divide both sides by 9.8. So what is going to be the value of T? Well, let's take our calculator and then we check on that now. So if I check it, I will have 12 divided by what? 9.8. 9.8. And remember that I said all answers, you should run it up to what? 2 decimal places. So if I'm running answers to 2 decimal places, what do I have? The value here is 1.22. This is time. The unit should be what? Seconds. And that is the what? The value or the time that it took the what? The stone to what? From the point of projection into the what? Into the maximum height. So now we are at the maximum height. This is the time to reach the maximum height. Let's look at question number 2. What does that question say? Question number 2. All right. If I take the question number 2 is saying that when stone A reaches its maximum height, the speed of the stone B, oh sorry, I said what? All the same instant that stone A is what? Is projected upward, stone B is thrown vertically what? Downwards from the same height at an unknown speed V. Okay, refer to the what? The diagram below, right? And then the question says, when stone A reaches its maximum height, the speed of the stone B is 3V. Right. So here, this is the maximum height, okay, for stone A. And stone B is on the side. It was projected downwards. And we were told that before this stone reaches this point, what the velocity for this was what? Was 3v. So that is going to be what? The final velocity for this one. So let's take it that now this one is here and it's now going to return together with the what? With the stone A. So since I know the velocity of B at this point, I cannot use the time of A from here together with this, because now we are making the assumption the two are coming down together. So they are going to come down from what? From that same time. Alright, so let's see from that point and see what we need to do to calculate for that particular problem. So what I want is the final velocity for that particular problem. So if I want the final velocity, I can still make use of my Vf is equals to Vi plus what? At or plus Gt. Okay. And remember, I'm still using my upward motion as positive. So my upward motion is positive. What is the final velocity? The final velocity for this is 3v. Okay. And then what is the initial velocity? It's unknown. So if it is unknown, my initial velocity is still going to be what? V. And what do I know? I know T, which is what? 1.22. So we're going to do that. And I know G, which is also what? 9.8 meters per second squared. So let's quickly do that and do the substitution, and then we solve for that particular problem. Alright, so I'm given this. It is 3V. And this is V plus. Remember, this is what? Negative 9.8. Okay. And then I am multiplying that by 1.22. And I need to solve for V. So what do? Well, let's go and do that. 3V minus V is now equals to, let's multiply that. I am going to multiply this value by 9.8 and I am getting 12. So this multiplied by that is giving me negative 12. Okay. If I subtract this from that, what do I have here? This minus that is going to give me 2V. And that is equals to this. Okay, and I need to straight away divide through by 2. And then let's see what we're going to have. So V is now equals to what? It's equals to 6.00. 6.00 what? Meters per second. So now this is the what? The velocity with which the ball B. Now check something here. I'm going to show you something. Sorry, I think I made a mistake by not showing you that sign. This is negative 12, so the value is what? Negative. That negative sign, I got negative 6.00 meters per second. I have put the 00 there because I said all answers should be in 2 decimal places. So I have that there. Alright, now let's check. What is that negative sign telling you? The negative sign is telling you that what? The B is moving what? Downwards. So that is the direction of motion. And that's the reason why we have the value to be what? Negative. If I don't want to leave it like this, I can simply write it that therefore what? V B, okay, that is the initial value of the what? Initial velocity of the ball B is now equals to what? 6.00 meters per second, what? Downwards. And then I'll just write there downwards. Downwards. To tell me that now that is the velocity with which the what? The stone B is using to do what? To descend down into the ground. Alright, so let's solve the next question there. And the next question is saying, at the instant stone A passes its initial position, on its way down, stone B hits the ground. Calculate the height h. So let's look at it. Stone A was projected until it got to the maximum height, got to a certain point, then this B was going down. But now what the question is saying that after A has returned to its position here, this B was already on the ground here. B was down here. That is what the one asked, we were told by the question. And now the second is to calculate for what? The height from here to here, which is the h that we need to look for. One interesting thing we have to take note of is that the time from here to reach the maximum height is going to be the same time that it's going to take A to reach what? The initial position where it returned. So we're going to use that same time that we have out there. And now, because at that point where it has reached, we have already calculated for the velocity of B, and we got the velocity of B to be what? To be what? The velocity of B, which is the initial one, because now A is in the initial position of B, is what? We got 6.00. This is just the approximated value. If you use, because like when we were having the first calculation that we did, if you divide 12 by 9.8, you're not going to get exactly 1.22. So the only thing that we're supposed to do is when we're doing the next calculation for us to get this, we're supposed to substitute the actual value for this into that particular what situation. And if you do that, you are going to get a 5.98 meters per second, which is approximately this, right? So if I'm going to do the next calculation, which is going to be for this, I am not going to make use of the approximated value. I'm going to make use of what? This actual value to do the calculation. If you do this, fine. The examiner will surely give a range of answers which will still fall in there. So if you finish, we can still try it with this actual approximated value and see what we're going to have. All right. So which formula am I going to use? I am going to make use of the formula change in y is now equals to v initial multiplied by t plus half gt squared. And now the time is not going to be 1.22, but it's going to be what? It's going to be 2.44, because 1.22 plus 1.22 is going to give me what? 2.44 seconds. And that is the time I need to use, because from here to here is 1.22, then from here to here is also going to give me what? 1.22. So if I do that, straight away this initial velocity for A to come down now, I'm going to use it to calculate that one, because now I know the time that is going to take this one to reach, okay, that is the same as this is also going to use to reach the ground. So I'm going to have this, which is going to be 5.98, sorry, it's going down, so let me use my downward as positive in this case. Downward motion is positive, so my initial velocity here is going down, so it's going to be positive 98. I multiply it by the time, which is 2.44 plus half. My g is also going down, so 9.8, and then I'll multiply it again by 2.44 squared. And now let's take our calculator and see what we are going to have as the answer. If I take the calculator and I do all that computation, 5.98, okay, and then I am multiplying that by 2.44 plus what? The fraction is 1, or let's say 0.5. So let me quickly just do that. Let me just make it as 0.5. Okay, and I'll multiply that by 9.8, and then multiply it by 2.44 squared. And once I do this, what am I having? I am having it as 43.76 meters. So the displacement, which is therefore my h value there, okay, is what? Is 43.76 meters. And that is the what? The height. That is the height that we're told to look for. Alright. If you decide to use, let's try that and see. If I use this approximated value with the 6.00, let's do that and see. So in place of this 5.98, I am going to change that and put 6.00 there, and then let's see if we're going to have the same thing. So if I put 6.00 in place of that, what I am going to have, we're going to have what? 43.81. 43.81, and this is what? 43.76. And that is why I'm saying the examiner will definitely going to give a kind of a range. So if you have this value or you have this value, you'll still be what? My correct. All right, let's let's move to the next question. I know somebody is asking the question of what about the graph question? I know when you go there, there's a graph question. I told you in my last video that I'm going to deal with what graph questions. I'm going to do with analysis of graph of what vertical motions on its own. So I am not solving any graph question here until we deal with the graph analysis of graph. Then I'll be solving all the graph questions just for you to have a better and a comprehensive understanding of what. Okay guys, let's look at the next question, and this question is taken from 2016 Matric question, and that is question number 3 because we're still dealing with projectiles. And the question is saying, so let's look at the question now. The question says, a ball is dropped from the top of a building 20 meters high. Ignore the effect of air resistance. And the first question that we have there is what? Define the term free fall. If you are asked to define the term free fall, what do you say is a free fall? Wow. Free fall is just simply the motion of an object under the influence of gravity or a weight or a gravitational force only. That means that the motion in which the only force that is acting on that particular object is what? Is the force of gravity. No other force is acting on the object. The only one acting on that particular object is the force of gravity. That is what we refer to as what? A free fall. Let's look at the next question. Our next question is saying we should calculate the speed at which the ball hits the ground. The speed at which the ball hits the ground. That's the next question. Well, let's look at the question and let's see a pictorial view of the question. As I always tell you, the first thing to always do is to get a pictorial view of the question, and then that will help you to be able to solve the problem. So if you look at it, the problem that we are given, there is a building. So let's take that as this, and the building is of a height of what? 20 meters. And now a ball is now being dropped from here. We are dropping this. What we need to keep in mind is that in terms of projectile, if you drop something, it has no velocity. So the initial velocity for dropping an object is what? Is 0 meters per second. If I take this and I drop this, the initial velocity is 0 meters per second. If I throw this like this, I take this and I throw it, I need a velocity to throw that. So that velocity is not 0. But once I drop that, then I have no velocity for that. So the initial velocity becomes 0. So let's look at this. We are here. So our initial velocity is 0 meters per second. Here is the ground that we need to go in for. And let's see what the question is requesting for. The question is requesting that we should calculate the speed at which the ball will hit the what? The ground. Which means we are looking for what? The final velocity. The initial velocity is 0, but the final velocity is not 0. So we want VF here. Right. Within these two intervals, what can we think of? Well, we know this object is undergoing a free fall. So the only force that is acting on that particular object is the force of what? Gravity. So G is 9.8 meters per second squared. Well, I don't want to give the sign for now. We're going to look at that as we move along. So let's see. G is 9.8 meters per second squared. The final velocity is what is not known to us. Our initial is 0 meters per second squared. And the height is what? 20 meters, which is the displacement for that. So which formula becomes the appropriate one for me to use? Well, I am going to look at this and say, okay, because I am dropping this particular object, I'll say that my downward motion is positive. I want any of the quantities that is going down to become positive. So the formula that will be appropriate for me to use based on the information that I am given, I will say that it is Vf squared is equals to Vi squared plus 2G change in what? In Y. That is the right formula for me to use. So what we need to do now is to do a substitution and solve for the problem. So what is the initial? Initial is 0, so there's 0 squared. Vf is unknown, plus 2, and our G is 9.8 because anything going down is positive, so that's positive. And then we're going to multiply it by the displacement, which is given to us to be what? 20. And now let's see, Vf squared is now equals to, if I multiply 2 by 9.8, I'm getting 19.6. So that is 19.6 multiplied by 20. And what will that give you? So 19.6 multiplied by 20. And then we get in what? 392. So Vf squared is equals to 392. And what I want is Vf. So what do? I take the square root of each side. Here, if I take the square root is going to take care of the square, and then I'll be left with what? Vf. And if I take the square root of 392, so I do that, square root of 392, and what I am getting is 19.79898987. But remember, I told you all your answers should be in what? Should be in 2 decimal places. So here this is going to be Vf is now equals to 19.80 what? Meters per second. Now with what I have just done here, I can also write this because the sign is positive, and I said from the initial stage that anything that is going down is what? Is positive. So I can just simply write that Vf is equals to 19.80 meters per second what? Downwards. In that case, I am showing the direction. This is the magnitude, 19.80. The direction is what? In the downward direction. Because the sign here is a positive sign. Let's look at the next question. If I look at the next question says we should calculate the time it takes the ball to reach the ground. So it means we're looking for the time from here to the side. And if I want to look for the time from here to the side, what do I know? I still know the initial velocity, I know the height, I know acceleration. Now I know the final velocity. And the final velocity is now given to me as what? 19.80 meters per second. Alright. One important thing is if I decide to use the final velocity in my calculation, I don't have to make use of this approximated value. I have to use the actual value that I've calculated here in order to get what? The correct answer. Because if I use this and I get a final answer of that and I still approximate, that is going to be a double approximation. So to avoid getting that, so that the value is going to be higher, for the value not to be higher than what is expected, use the actual value and not the approximated value. So let's see. We want to solve that problem. So the question is asking me to calculate for the time to reach the ground. If I want to use the time to reach the ground, still I am taking my direction of motion, which is the downward motion, to be positive. And if I take that to be positive, then I should have Vf is equals to Vi plus Gt. Because what I want is now the time. And I know this, I know this, I know this. So I can calculate for that. If I want to use this, the value, what do I have? It is 19.7989. Okay. Right, so let me use it at 90. Let me use 4 decimal places because that will be very correct. And then my initial is 0 plus G, which is 9.8 multiplied by T. And what I want is to find my T. So what do? This is 0, so I will have it as 19.7990 equals to 9.8 T. I divide by 9.8, I divide by 9.8. What do I have? T is now equals to. Okay, so 19 point all that divided by 9.8. 9.8. And then my answer is now going to be 2.02030589 seconds. Okay, seconds. And I want to now leave my answer in 2 decimal places. So that's going to be what? 2.02 seconds. Right. So this is the answer to that problem that we are given. That is the answer to that problem here. That's it. So this is the time. It's going to take the what? The ball 2.02 seconds to reach the ground. All right. Let's move on to the next question. All right, so here is the next question. This question is not a metric question. It's a question that is picked from a textbook. And the question says, a ball is thrown up at 15 meters per second. And the question says, question number 1 says, how high after 1 second? And the second one says, how high after 2 seconds? So we want to find how high. And once we speak of how high, then we are talking about what? We are talking about the displacement. All right. So let's go straight away and calculate for how high after 1 second. Right. If you look at it, this is the ball here, and the ball is being projected up. Okay, and it was projected at 15 meters per second. It is projected 15 meters per second. That is the velocity, and this is the initial velocity with which the ball is moving with. Right. Now we need to find how high. Okay, so if you want to find how high, the only thing that is given to us is this, and we know our what? Our G, or the A, and we know that is what? 9.8 meters per second squared. Right. That is the acceleration due to gravity. And now the question wants us to find how high, so it means we're looking for the what? Delta Y. Okay, so delta Y is what we are looking for. And if you're looking for delta Y, what we need to know, which of the formulas is appropriate for us to make use of. Remember, the ball is projected up like this, so the ball is going to go up, and then the ball will return back into the ground. That is how it's going to go. So let's try and see from here now. All right, I will just say that change in Y is now equals to VI, okay, T, or change in T plus half GT. I'm going to use GT, which is the same as A, change in what? Change in T squared. Right. Let me put change in T and make it uniform. Right. There is the formula that we're going to make use of to do the calculations straight away from here. So if I want to do this one, then let's see. Change in Y is what we are looking for. What is the initial velocity? Remember, I need to take what? My direction of motion. And in this case, I want to all along I've been solving upward as positive. So pardon me to use downward as positive in this case here. So I'm going to use my downward motion as positive. So here, anything that is going down is positive. So I'm taking my downward motion as positive. The initial velocity is going up, so that should be negative. So straight away, I am going to have it as my negative what? This. Right. And remember the question one, how high after what? 1 second. So our time that is given to us in this situation is what? Is 1 second. Right. So I want that time, which is 1 second plus half, and then the G. G is going downward, so G is going to be positive, and that is 9.8. and I'm multiplying it by what? 1 squared. And then let's do the substitution straight away and solve from here. Alright, so I need my calculator to do that, and if I take from here, if I multiply this by that, I'm getting negative 15, okay, plus, if you square 1, that is going to be 1, and if you multiply 0.5 by 9.8, we're going to get what? 4.9. And then let's do straight away from here. So I have 15 plus okay, that is negative 15, so negative 15 plus 4.9, and then what are we getting? We are getting negative 10.1. And remember, I said I'm leaving all my answers in 2 decimal places from the beginning or from the initial stage. So therefore, I'm going to add 0 here to make it complete. And this is what? This is displacement. How high is the displacement? So that is going to be what? In meters. So the unit is in meters. So change in y, how high that object is going to be after 1 second is going to be in what? 10.10 meters above the what? Above the ground. Now let's see. This is how high it is going to be. If I want to write this, in this case, I can also write it as change in y is equals to 10.10 meters where. This is where? This is negative. And we said from the initial stage that anything that is going where? Is going downward is positive. So if my answer is negative, it tells me that object is still going what? Upwards. So I'll say it is 10.10 meters what? Upwards. So that means that the object is still on its way up. It is still on its way up. So that is it. I put it in this way. That is it. Straight away, and that becomes my answer for that. Let's look at the next one. And the next one says we should find how high after 2 seconds. This is after 1 second. This is where we're going to be. The object is going to be on this point. So after 2 seconds, where will the object going to be? Okay. So after 2 seconds means that wherever we see the 1, we are going to put 2 there. I'm still going to maintain my upward, my downward as what? As positive. Again. So my downward is now positive. Let's go on and let's see. Alright, so here is that. And remember that here this time around my change in t is now 2 seconds. So I put that in there. Change in y is now equals to negative 15 into 2 plus 1 over 2, and my g here is 9.8, which is positive because downward is positive, and then multiply that by what? 2 squared. And if I do this, I'm having negative 30 here plus this is 9.4, okay, and then I'm going to multiply that by, when I square 2, I'm getting what? 4. So let's do that straight away. Punch that into the calculator. We're having negative 30 and then plus 4.9 multiplied by what? 4. And then let's see what we're going to get. So I just want this to be the right way, so let me put all that into bracket. Okay, all right, put all in bracket and then work out that. And then what are we getting? We are getting negative 10.4 what? Negative 10.4 meters. All right, so therefore that also tells me that still the object is what? It's still moving upwards. So it is 9.40 meters what? Upwards. The object is still going up. It is not yet down. The object is not yet at what? Returning back into the ground. So this is the what? Is how high the object is going to be after what? After our what? After the object has traveled what? 2 seconds. Thank you very much for watching this video, and please, if you have not subscribed to our YouTube channel, do so by subscribing to the YouTube channel. And as you subscribe, please click on the notification bell so that anytime we release any new video, you'll be the first person to watch it. And please, as you subscribe, share with your friends and give comment, for your comment is very important to us. As what I'm going to say to you is that keep learning, for learning is life and life is learning. See you next time, and bye bye for now.